an electric field is uniform, right? And in the positive x direction, and it is in the positive x direction for positive x, the uniform electric field with the same magnitude but in the negative x direction for negative x. It is given that electric field is 200 I cap. So electric field is 200 I cap Newton per Coulomb, right? This is when the value of x is greater than 0, whereas the same electric field is given as 200 minus I cap Newton per Coulomb when the value of x is less than 0. So thing is, we need to put a vector symbol on top of it, right? So there is a right circular cylinder of length 20 centimeter and radius 5 centimeter, which has its center exactly at the origin. So there is a right circular cylinder which is having its center exactly at the origin, right? And its axis along the x-axis, so that one face is at x is equal to 10 centimeter. So this face is at x is equal to 10 centimeter, and obviously this face will be at x is equal to minus 10 because the origin is the center, right? So when you take this to be 20 centimeter, right, the radius is going to be 5 centimeter. So what they are asking is, what is the net outward flux through each flat face? What is the net outward flux through each flat face? If I take this to be x and this to be y. Okay. So this is the first flat surface, this is the second flat surface, and this is the curved surface. So when I look at the first flat surface, so what is the flux through the first flat surface? Observe, the electric field here is going to be 200 I cap. No doubt in that. Right. What about the area? If I take the area, it is going to be in the outward direction. Is there any doubt in that? I hope it's clear. Right. So aerial vector is in this direction. Now, what is going to be the flux through the first surface? Electric field is uniform. Area is known. So you will write it as E vector dot A vector. So what is E vector? 200 I cap dot, what is A vector? Pi into R square, that is pi into 5 into 10 power minus 2 the whole square. Why did I put 10 power minus 2? Because this 5 is in centimeter, 10 power minus 2 meter. So here I have I cap, here also an I cap. Now the scalar parts get multiplied. So what can I write here? 200 into 5 square is 25 into 10 power minus 4. I cap dot I cap is going to give me a 1. Right. So into there is a pi. Okay. Now tell me, what should I do? So 25 into 200 is going to give me 5000. So 5000 is 5 into 10 power 3 into 10 power minus 4 into 3.14. So 5 into 3.14 is going to give you 15.7. Okay. Into 10 power minus 1. So it is going to give us 1.57, right, Newton meter square per Coulomb. Am I clear with this? So this is going to be the flux through the first flat surface. The question is very clear. They asked through each flat surface. So flux through the first surface is phi 1. What about the flux through the second surface? This is what we think, but the answer will be the same. Reason? Not magnitude. Electric field for the left hand side is in the left side direction. Aerial vector is also in the same direction. So when you solve this, when you do this E dot A, right, here also you have cos 0, here also you have cos 0. So you will get exactly the same answer, not get the negative value. You would have got the negative value had the electric field been in the opposite direction. See, it's very simple, okay? Whenever you have flux to be a positive value, remember this. Flux positive means it is leaving the surface. Flux negative means it is entering the surface. Okay, so that is another symbolic representation. So phi 1 and phi 2 are same. That's what the answer for the first part is. The sorry, first and the second part. So what about the third question that they are asking? What is the flux through the? So, but they asked about the second part also. No, what is? So sorry, this is the answer for the first one. Flux through the first and the second surface, second flat surface. What is the flux through the side of the cylinder? For the side of the cylinder, this is going to be the area. It is in the upward direction. Electric field and aerial vector are perpendicular to each other. So, the flux through the third surface is going to be how much? 0, since electric field and aerial vector are perpendicular to each other. Cos 90 is going to be a 0. Now, the next part that they are asking is the total electric flux. So, total electric flux is going to be phi 1 plus phi 2 plus phi 3. So, 1.57 plus 1.57 plus 0. So, it is going to be 3.14 Newton meter square per coulomb. So, the total flux is going to be 3.14 Newton meter square per coulomb. And the last part that they are asking is, what is the net charge that is placed inside the cylinder? Net flux, sorry, when you need the net charge, Gauss law states the total flux is equal to the charge enclosed divided by epsilon naught. So, what is going to be the value of charge enclosed? Total flux, that is 3.14 into epsilon naught, which is going to be 8.85 into 10 power minus 12. So, when you multiply both, that is going to give you the answer, right? So, those many coulombs will be the answer. Am I clear with this?